Hello, my name is Ahmad Akori bin Ishaq. My metric number is A22A0714. I want to talk about the introduction of statistic. Statistic is a branch of mathematics used to summarize, analyze, and interpret a group of numbers of observation statistics. Statistic is also the practice or science of collecting and analyzing numerical data in large quantities, especially for the purpose of inferring proportion in a whole from those in a representative sample. There are two major branches of statistics, which are descriptive statistics and inferential statistics. Descriptive statistics involve the organization, summary, and display of data. Meanwhile, inferential statistics involve using a sample to draw conclusion about a population. The objective of this study is to learn how to collect the data set using SPSS, describe the data set using the descriptive statistic, represent the data set graphically, and perform the statistical analysis using SPSS. The next part is data description. The data set you have is a collection of information related to life insurance charge. The data set contains 1339 observation and is in SPSS format. There are several variables included in the data set, such as age, gender, body mass index, BMI, number of children, indicator if the insured is a smoker or not, the region where the insured life, and the value of life insurance per year, ringgit Malaysia. These variables can be used to analyze and understand the factors that influence life insurance charge with this dataset. You can identify correlation and trends between the variables that might help you make informed decisions about life insurance charge.
Hi, Assalamualaikum. My name is Muhammad Zulfitri bin Maznan. My number is A22A0562. So today I want to talk about numerical descriptive measures. So kita dapat lihat yang 31 itu measure of central tendencies, iaitu dia ada mean, median and mode. So dalam mean, median and mode adanya age, iaitu umur, children, iaitu kanak-kanak, dan juga BMI. So kita dapat lihat iaitu age mempunyai mean sebanyak 40.06, manakala median mendapat 28.5, mode mendapat sekitar 23.40. Manakala kanak-kanak iaitu children pula mendapat mean iaitu 1.21 dan median pula adalah 1.01 dan mode pula mendapat 0.88. Manakala BMI pula mendapat mean merupakan 3.01 dan 0.05, median pula mendapat 2.61 dan yang terakhir mode pula mendapat 32.43. Dan seterusnya kita lihat daripada segi 3/2 iaitu measure of population. So kita dapat lihatlah bagaimana pengiraan Q1 dan ini adalah formula untuk mendapatkan orang kata first quartile dan third quartile. Dan kita lihat jadual yang mana susunan kelas yang bermula daripada umur 18 tahun sehingga 66 tahun. Dan kita juga ada children yang kelas 1 sehingga kelas 5 dan mempunyai first quartile dan third quartile juga. Dan yang terakhir adalah 3/3 iaitu measure of variation, iaitu dia ada age samalah dan juga children, dan hasil pengiraannya melalui formula yang telah diberikan, formula yang telah dibaca dan sudah ditarifkan, dan pada akhirnya solution dia mendapat 1.0725. Terima kasih.
Hi, Assalamualaikum. My name is Muhammad Amir bin Syamsuddin with metric number A22B1002. Today, I'm going to present about graphical representation. Graphical representation refers to the use of chart to clearly visualize and simplify data set. Data is entered into graphing software and then represented by a variety of symbols such as line in a line chart, bar in a bar chart, or slice in a pie chart. Besides, these two variables are quantitative variable data, so the both can be represented by scatter plot, histogram, frequency polygon, or OGIF. In this part, we will use a OGIF or cumulative chart and a histogram to represent the age and children. For OGIF or cumulative frequency graph, a cumulative frequency graph or OGIF is a line graph that shows the cumulative frequency of each upper class boundary. To draw an OGIF to represent the age, several steps are required. The first step is to create a table of frequency distribution. The table must include cumulative frequency as a vertical scale of y-axis. and upper class boundary as a horizontal scale or x-axis. After creating table of frequency distribution, the upper class boundary are required to plot on each class in the x-axis with their corresponding cumulative frequency, and each of the points must be plotted and connected from the left to the right. The ogive must start at the lower boundary at the first class where cumulative frequency is 0 and should end at the upper boundary of the last class, which is equal to the sample size. For ogive or cumulative frequency graph, x-axis is for upper boundaries and cumulative frequency is y. For the first upper boundary is 18.5 where the frequency is 0, and second 24.5 where frequency is 70, and the third is 31.5 where frequency is 127, and the fourth is 38.5 where the cumulative frequency is 168. The next is 45.5 where the cumulative frequency is 110, and next is 52.5 where the cumulative frequency is 256, and the second last is 59.5 where the cumulative frequency is 316, and the last upper boundary is 66.5 where cumulative frequency is 350. Next is histogram graph. A histogram is a bar graph that represents the frequency distribution of dataset. Drawing a histogram has several steps. The first step is the horizontal or x-axis scale is a quantitative and measure the data value at the class midpoint or class boundary. While the vertical or y-axis scale measure the frequency of or percentage of the class. Besides, the consecutive bar must touch with each other. The bar must begin at the end at the class boundary instead of class limit. For the histogram graph, the x-axis is for a midpoint and the y-axis for frequency. For the midpoint on 0.5, the frequency is 235, and for the midpoint of 2.5, the frequency is 105, and the last midpoint is 4.5, where the tank frequency. Therefore, we can conclude that the highest are between 0 to 1 because it's the highest frequency.
Hi, my name is Muhammad Afif Memunir and my number metric is A22A0135-5MO, Statistical Analysis Using Software. 5.1 Numerical Descriptive Measure. The median for one age, the median and mood of the number by using the software SPSS is 39.552, 40.0 and 19. For the graph, the shape of distribution also skewed to the left. For 2 BMI, the graph, the shape of distribution also skewed to the left. For the third children, graph, the shape of distribution also skewed to the left. Statistical analysis using software. Numerical descriptive measure of central tendency. For age 1, age mean manual 40.06, median 28.5, mood 23.40, SPSS 39.52, median 40 and 90, mood. BMI, so mean manual 301 and 5, median 26.1, mood 32.43, SPSS 30.6, 30.25, 26.60. For children, mean manual 350, SPSS 1.09, median 1.01, 1.0, mood 0.8 and 0. 5.2 Hypothesis testing. T-test. For 1H, step 1, step 2, signification level A 0.05. Step 3, test statistic, 1 sample test. Step 4, decision rule, critical region. Step 5, conclude that the mean number of age is more than 39.55. 5.2.2 ANOVA. Step 1, all at treatment means are not the same. Step 2, A 0.05. Step 3, test statistic. Step 4, decision rule, critical region. Step 5, there are no significant difference among the treatment. Fail to reject signs F 1.385.
The conclusion is income, price, and age are the variables that have been chosen from several variables from the dataset. 350 data we randomized selected by using the SPSS software. Measure of central tendency, measure of position, and measure of variation we manually calculate. SPSS software we use to do the statistical analysis. The result of the hypothesis testing for ANOVA analysis is failed to reject. HO for correlation, we can conclude that there is no correlation between three variables.